So, this demo is based on the topics that we have covered in the last 3 modules. In the last 3 modules we have covered on the topic input output streams in Java, and as we know the input and output is a very important one, what is called the activities, is a very important activity in any program development. And in order to make this diversified input output process, that means input from the different sources, output to different sources, there are many mechanisms, rather many ways has been devised in Java system. Now, today we will discuss about how the different way of input output is possible. There are some trivial input output mechanism, those are related to the standard input and then standard output, namely keyboard and then display unit. We have already covered, we usually used it in our previous programs, but here we will discuss about other than the standard input and output, how we can store some data into memory, or we can retrieve something which is stored in hard disk like. So, our demonstration includes how to create, how to open and close a file, how we can create our own file, and there are again 2 different classes, rather we can say the ways, the byte stream classes and then character stream classes to read and write into file from file by means of data input stream and then data output stream. So, we will discuss about the usage of these 2 classes to create files, to access the data, all these things. And then we will discuss again file handling Java in Java. So, file is basically secondary storage, right. We can store some data in a permanent non volatile way into the secondary storage space. So, how we can create a file such a secondary storage, and also how we can open, how we can copy, how we can merge, so many other things are there. And few advanced methods, they are called buffer input stream and sequence input stream. To make our programming easy, we will discuss in this demo. So, let us have the demo first thing, and this demo we can start about from very simple idea about using the data input stream class. We have already familiar to this class in our earlier discussion, we have used it. So, data input stream class, as the name implies that it will basically for the input purpose. That means, using this class we can read something from some sources. Now, here we will see exactly data input stream class can read from memory, can read from network channel, it can read from standard input device. This example illustrates how the data input stream class can be configured, so that we can read some data from the standard input, namely the keyboard. As you see the program here, so this is the main method. As you see here, in this main method we create 2 fields, namely the principal amount and the rate of interest, for which we want to read the value from the keyboard and the number of years also. So, the 3 inputs needs to be collected from the user through keyboard. Now, here basically we create an object called in, and this is the object, that object is created, and then this object, once that it is created by means of a constructor where the input is basically system.in. Now, system.in implies that it is a standard input. The system.in, this is already defined in the java.lang. So, from there it will get the definition. So, it is basically is a standard input. Now, so basically what we do here, that we create an data input stream object which basically connect your program to the keyboard. Now, let us see, we give an prompt to the user that enter principal amount. Here basically we have discussed about that flushing, that means keyboard has its own buffer. So, we have to clean the buffer each time we are going to read from it. So, system.out.flush is basically clean it is. Now, here then okay, so it will read from the object in here that means which connect the keyboard, and then in dot read line. For this method, read line means it will read the entire content that is there in the buffer. So, the entire whatever the value you will enter, it will read it here, but as you know the value that will be there in the buffer, Java program read it as a string. So, we temporarily store this in the string format here. So, it is basically read as a string, although user may have entered some value say 565.25. So, it is basically floating point or double value. Now, here we convert this string value into our double value or float value. So, using the float method for this in the class float, which is defined in the java.lang package, and for this class there is a method called value of, and this is a static class actually. So, we just convert this string into the float value. Now, again we give the another prompt, enter interest, again we flash it and then read line, again read the buffer, and then again convert this string into the float value which stored in the rate of interest. So, again then we read the integer number from the read, we convert it into integer format, as initially it is a string, and then store the value is the number of years here. So, this is the way we can read the 3 inputs from the standard input, that is the keyboard here, and then finally we calculate. These are the trivial process. Now, the main thing here we can see, we can tell here is that how using this data input stream class we can create a stream object which connect your program to your keyboard. So, the stream can be propagated from the input source to the program. Anyway, so this is a simple program we have already familiar to, and we have discussed it many times earlier, and other than this class also there are many ways the input can be from the standard device like command line input, and then the using the scanner class which is defined in java.util package, we can run all these things. Now, our next example that we are going to discuss about is basically, as we have discussed about, all the data input stream class is basically the twofold, using the byte stream and then character stream. Our next example, this example is to illustrate how we can output to a file which is stored in a secondary storage, and we can propagate the output from the program to the file in the byte form. As you know, byte is the smallest unit, a chunk that the Java program can handle it. Now, here is the program as you see here. Okay, first we have to import java.io.file output stream. This is because we want to propagate the output to a file, and this is the file output stream class is defined in the java.io.package. So, the import is must. Now, here is the main method. As you see, we create an object. The name of the object is fout is basically of type file output stream, and here you see the constructor. The file output stream has its own constructor where an argument is required, is basically the target. So, here actually the target we have mentioned explicitly where we want to store this content. So, as you see, it is in the D drive. Under this D drive there is a directory demonstration, under this demonstration XII, and then this is basically the target file name test.txt. So, you should explicitly mention path of the file where you want to store your data. So, this is the way that we can do it. Now, here you see for this object fout therefore object is basically the connection from your program to this file test.txt. Now, from the program we can write 65. Now, 65 is basically here in integer form, but it will be converted to a byte form. As you know, the 65 byte, in the byte form it is basically capital A character. So, ultimately although we give the 65, your program, the system will convert into it a byte, that means 65 in the byte is basically the ASCII code is A. So, A will be stored actually in the file, and then finally once the file is open we have to close the file. It is always, you should close your file always once your task is over, and then finally it will print the writing is over. Now, this program, as you see, this program will write 65 in the bytecode form into a file test.txt. So, after the successful execution of this program, we will see the output file here test.txt, that way 65 is stored there or not. So, this program is run successfully, and then output file is here, the test.txt. Test.txt is now displayed, as we see it basically store A. Now, in the same program, if we again write 90, f out write 90 type it no, another write 65 is there, okay, right, yes, in addition right. Now, we are writing another 90, as you see it will append after the first 65, that means A, and corresponding to the 90 byte code, it will be stored there in the same file again. Now, here the same file can be a z. So, z is basically the ASCII code for the 90. Okay, so, we have learned about how in the byte form, we will learn more about in the byte. So, the next example, suppose you want to store an array of elements into a file. Here we can give an idea about how using the byte code system an array of elements can be stored into a file. Now, this program, as you see the main program, we first create an array of bytes. So, here D, E, all these are basically the ASCII value within the single code, whatever we mention, it is basically the ASCII value of that character. So, capital D, E, L, H, I. So, ultimately like the previous program, as we see this is the bytes way it will store, but it will store now in the array, and this array is basically byte array, because it is declared as a byte type array. We can declare float, integer also, that way it will store the integer from that way. Anyway, so this basically now we create one output objects, out file is a type of file output stream very similar to the previous one, and then we decide it is a create the object, and finally we make a connection that where this value will store. So, for this object out file we establish a connection to, this is the location. So, the location is as you see location is city.txt, that means this is the output destination target, where the output the entire things whichever here will be there, and then finally we write the entire array here. So, passing the array name here and finally close, it is the same as earlier. Now, okay. So, this way the entire array elements will be stored into the file. Now, let us run the program, and finally we will be able to see the file, in this case city.txt, which store all the values that is there in the byte array. Yeah, okay. So, file has been written successfully, and then we will be able to run the, we will display the city.txt, as we see here Delhi, Mumbai, London, these are the basically ASCII character as it is there in the byte array. So, it is basically stored successfully. So, this program says how an array, and a similar way this program can be extended to store any array actually, whatever the way, you can use the byte array, rather you can use the character stream classes also, whatever it is there. So, an array of elements can be stored, a single element can be stored, and like this. Here we are storing all these things in our memory. Now, our next example, again using file output stream classes that we have discussed, that we have to copy some text using again byte array stream into the same file. Now, here is the program, as we see it is the same file output stream class. Here file output stream class create the object, and we just connect it to one target test out.txt, and here we create a string, here welcome to NPTEL. Here a small string we have considered, many other large string also we can include, say other things also we can input here. For example, type here welcome to NPTEL, hope you are enjoying Java programming, hope you are enjoying Java programming. Okay. So, this is the text, whatever the text, maybe here only few characters, very big, I mean very large file also can be considered. I will discuss about how a file can be, entire file can be copied here. Anyway, our objective is that this string which is basically here in the program, I want to store into a file, the name of the file is testout.txt. Now, we first store this string into the form of a bytes. So, here is the mechanism for a string object, how we can convert into the bytes. So, basically string, this is the string and we converting the entire string content in the byte. So, get bytes is the method for the string class which is there in java.lang package. So, we temporarily store into an array, byte array. It is the similar to the city array we have as discussed there. Then write method for this file output stream class, which basically write the entire array. It is all same as the earlier one, and close, and finally file writing is over prompt, and then it will there. Now, we see after the successful running of this program, we will see one file testout.txt has been created, where we could store that string which has mentioned there. Okay, fine. As you see, this is the yes. So, now we are displaying the file content. As you see, this is the content has been pushed to the file which we have displayed there. Now, so this is the way that now so far what we have done is that we can create something, we can store something from our program to file. Now, we will learn about how to read a content from a file. Now, this is a very simple program for this purpose. For reading some content from the file, we have to have the create object for the file input stream class. So, file input stream class, because we have to go for input process, and this fn is the name of the object of this class we have created, and this is the usual process of creating the object and giving the explicit mentioning where actually from which file we want to read. So, in this example we want to read something from testout.txt, which file we have already created, like welcome to NPTEL Live, and here int I fin read. You little bit carefully observe for the fin object means that is the connection from this program to this file. We invoke the method read. Now, read method always read one character at a time. So, this means that the whenever we create the file object here, it basically point to the first character in that file, and it will basically read that character, and this character actually returned by this read method as an ASCII value of that character. That means, it will read there, and finally, we can print this character by casting it. That means, its ASCII value will be converted to the character corresponding to this, and it will be stored there. So, you can note that in the previous example test.out, we have stored the welcome to NPTEL. So, W has been stored there, and W being the ASCII value, and then it will be access it, and then it will display from your program. Now, here we can see, here we can see W is being printed. Now, if I little bit change this program without casting it, you can see here without casting it, we can run the same program again, but only its integer value. Rather, it is basically not ASCII code, it is a ASCII value. Now, here we see we print here in case 87, and 87 is basically the ASCII value for the ASCII character W. So, this is basically the way. Here exactly we save this program earlier in the bytecode form. Here we read in that ASCII form, byte form, and then printing into its character. So, conversion is possible. So, this means actually I want to emphasize is that whatever the way in the byte or character you can do it, and you can read it also, no issue, it is there. Now, we will learn more about regarding the character stream classes. As we have seen in the last example, we could read only one character from the file. If we want to read the entire character set of string text from a file, what is the program should look like? In this case, again we have to create an object for the file input stream, because we want to read a file, and here is the object the same way we created the object fin, and this is the, for example, test out.txt is the target file from where we want to read the entire text. As you know, in this text we have written welcome to NPTEL, hope you are enjoying Java programming life. Now, here this basically is the loop, because instead of only single character we want to read it all the characters which are stored there in this test out file. Now, fin.read is basically to be looped until, here is the condition, this is very important, not equals to -1. So, not equals to -1 Java implies that it is the end of file. At every end of file, whenever you put file close, the Java put a -1 there, indicating that this is the end of the file. So, -1 is a termination condition for a file object. Now, it will basically read the file content, and here the content which will be read from there, file input stream means in the byte form, we convert the character, and those things will be converted and printed on the screen, and finally, once the entire file is scanned, it will basically close. And here you can see it will read the file sequentially, the first, then second, then third, and so on until it will reach to the end of file. So, this program again, as you can understand, anticipate, if we run it, it will basically extract all the content which is there in test out.txt and display on your terminal. So, I am running this program, and then we will see after running. So, this program, as you see here, it basically show the output enter which has been accessed from the test out. This is the basically content which we have stored in the test out file, and is to access it and display it. Now, so we have learned about how we can open a file, and then from that file we can read the content in the form of a byte. And our next example is basically regarding the file status checking. So, it is a 12.6 program, we are going to see about it. Now, here you know, so far the status of the file is concerned. Whenever we store a file, our operating system maintain all about its file, that means in which directory, what is the name of the file, what is the extension, whether the file is in which mode, readable or writable, whether file is available or not available, whether file is corrupt, whatever the information it is there. So, it is basically the program which all these information can be accessed from the program site itself. Now, here we can see this is the program, and it is basically two methods we have discussed here in this class. This is basically our main class. The method is get paths and another method is get info. Now, so far the get path method is concerned for a object file object. So, file is basically one class which is defined in java.io package. So, dot star includes that file package, file class needs to be accessed. So, file, for this we will pass this file object whenever we call this get path. And now, here we see this get path method includes simple three statement, namely it will basically give the name of the file, f.getName, the name of the file, f.getPath, which path actually it is stored, and f.getParent, what is the parent if it is there. And then, so far the get info method is concerned, if the file exists, that means if file is not null, file exists means you can pass information which is no more exist. So, in that case, if it is exist, it will just exception. If it exists, it is true, then it will go for this printing f dot can read, f can write. That means, it basically whether this file is readable or writable, read mode or write mode, read permission, write permission. And then it also say the last modified, whenever you create a file, system always store at the last modification of the date of this one. So, this one, and f dot length is basically how many bytes basically are stored there in this file. So, these are the information. Now, let us come to the main method here. So, this is the main method, this is the main method. Here basically we create one file object, name of the object is file to check, and then if args.length, basically we can pass the command line input so that we can run this program for as many file you want to check for it. So, it is basically args.length in that sense, and for each file argument we have passed it, it will basically call the get paths and get info method that means it will retrieve all the information regarding the file name, path and status of it, and finally it will come to the end of this program. Now, we will run this program passing 3 input as a command line, and say the input is say ct.text. We know we have created one file, text.txt and testout.txt. These are the 3 files are already we have created. Now, so we can see, we are running this program using passing 3 input ct.txt, txt.text and testout.txt. Fine. Now, here you can see the output, as you see path test.txt, parent, there is no parent actually indicating null, and then and is writable, last modified, this is basically the system time, it is in a some tick form, and then file size is 2 bytes. Now, name ct text, path is ct text, parent, there is no parent for this file, readable file it is, also it is writable, last modified this one 20 bytes, this also like this, and here you see text.out, text, this basically file does not exist, because this file actually it is not there, whatever it is there. So, whatever the file we have passed to the program, this program from side it can check the status and can show you. Now, we have discussed about so far the byte stream classes for reading as well as writing. Now, it is our turn to learn about other classes. So, for the file handling is concerned, they are called file reader and file writer class. Now, we are going to have a demo here. In this demo, we will see how we can copy the content of one file into another. So, basically making a duplicate and using file reader and file writer class. So, this program again we make the program for illustration as simple as possible. We can see we first create one object in file for the file. This basically create a connection from this program to this target date input.data, assuming that input.date file is already there in the system. If it is not there, then it will throw an exception, because file opening will not be possible. Anyway, so this is also another out file, and this basically where the content will be stored. So, here we have created 2 files, in file and out file, for the 2 purpose. But purpose is that reader and writer. So, I just create an object ins, so that in file can be used for the input purpose. That means, from in file I will be able to read something. So, ins and outs are the 2 objects of type file reader and file writer for the input and output mechanism. Now, here for ins we create the file reader object for the in file. So, in this case in file means it is basically input data. So, in other word ins basically a connection from your program to in file. In file means input.dat. Similarly, outs is the another connection from your program to out file, that is the output.dat file. Now, here basically we have to read each and every characters, those are there input.date, that means in file, and then write into the out display on the, it is basically read the entire file and then outs write means it will store into the output file. Here we see the statement that we have ins read means read one character from the file at a time, store as a ch, the temporary store, and then the same ch it write into the output file outs. So, reading one character from the ins and writing the same character into the outs, that means input date and output date. So, this program, and also we have filled up with try and catch. You have to always use try and catch block, as there may be some situation where unwanted situation, whenever a file is not accessible, the file read permission is not there, write permission is there, or file is or no more memory space is available. To avoid so many situations, we have to handle the exception. So, those things can be done by try catch mechanism. So, you have to handle for every occurrences, either creating file or reading or writing, whatever, right. So, they should be put into the try catch block there. Now, here is basically as we see the output, welcome to NPTEL is the input.dat file. and we copy this the same content and also create the output file. I will come to NPTEL. So, we created that duplicate of one file input dat, the name of the duplicated file is output dat. So, we have learned about how a file copy is possible. Now, here is another example. In the last example, we have discussed that copying the file using character. So, it is basically character stream classes. We want to do the same thing again, but using byte stream classes. The difference is that in the last example they will read as a character, but here they will read as a byte, that is all, but the mechanism is almost same. But there is again a reason that when you have to read character, when you have to read byte, whenever the heterogeneity is concerned, then you should use the byte stream classes, and homogeneity means in the same system whatever it is there. You have created the file in Mac OS and want to read from the Windows, then obviously byte stream is the best procedure, but if it is the same system Linux to Linux, then you can use whatever method you can. So, byte stream is always preferable. Now, here is the program, as you see the same as in file and out file are the two file input stream and file output stream object. We create the connection in file, passing this is the target, is the input source, is the target, that means where the file will be stored there. Now, here is the only mechanism, it is different than the previous one. So, here byte read temporarily we store here as a byte in full read, it will read from the in file, store in the byte form, and it is a byte. Okay. And then byte read is again, while this is not equals to -1 mean you have to scan the entire file. So, you have to go for loop and it read one byte at a time, and the same byte is write into the output file, and again go for reading the next, and then loop continue and until this one is there. Now, input dat, as you see, we will come to NPTEL is stored there, and here out dat file will be created now if it is successfully copied from that file. So, mechanism is little bit different, but the objective is same. Objective is that we are copying from file to another file. Yeah, file has been created, out dat file, we are going to display the out dat file. Yeah, this is the out dat file. You see, this is the content of the file that we have obtained it after successful completion. Now, so this is the idea about. Now, before concluding our demonstration, we want to have two more programming illustration. This is the utility of buffer output stream class, like also buffer output stream, buffer input stream. In our next two examples, we will demonstrate how the buffer output stream and buffer input stream is possible. It is basically same thing, the same idea about byte stream actually, but you use the another class that is there already Java JDK called the buffer output stream class. Now, let us have a quick look at this program here. We just create file output stream object because we want to read some, we want to write into somewhere. For the file output stream, we want to write something into test out1.txt. This is basically our target file where you want to store it. From our program, we want to put somewhere into this target. Now, let us see what is the program that we want to put. String s, welcome to NPTEL. This means that we want to write this string into this one, but here we want to store it using, this is the object, the buffer output stream object called the b out. So, is basically b out is a buffer output stream, is basically is a connection from the f out. So, f out to this one, that means it will channelize the content and then is stored in the buffer output stream form, and then will this one. So, here this string s will be from our program, and we convert in the string, and here write b byte, and then we will store into the b out form. Now, this is the idea about that byte buffer output stream classes is there, and this kind of program, although we are storing from our program, but instead of this program, if it is a network source, at the moment we do not have any network experience. So, we will not be able to do it with a networking example, but here this S can be from say network channel. Now, you will receive the buffer output stream from the network, whatever the stream will come, we will buffer it first in our local buffer, and from that buffer we will push into the file, target file. So, basically suppose you are downloading an image from the website, and then this image can be a very large one. So, we will be buffer into. So, in that case we should use buffer output stream object, so that we can store an image as a buffer form instead of the entire image can be pushed there, because entire image is too large, maybe few MB, and you cannot put it there. So, it is a buffer form. So, for this purpose we will do it. Yes, likewise buffer input is basically if we read very large image from the channel network and writing into a network line. Okay, now let us see here how we can write these things into this one, and okay. So, here the file is successfully contained. Here we can see directed our output to a file, but here instead of directing this file we can direct it to some network port. So, that through network this can be transmitted. We will see about the network whenever we will cover the networking in this module, in this course. Now, the next example just opposite to this byte output stream buffer, here the byte a buffer input stream class. Same problem here, basically here we just create the buffer input stream, that means we will read something. Here we will read again from this object out.date, out.date is already stored there. So, instead of outdate, here we can in this source we can make the network port number, socket, all these things. Here we will just give the output in source of the input, and then it basically read the entire content and then read in the form of a byte and then print on the screen. So, it is basically the idea about buffer input stream and then buffer output stream concept. Yeah, this program as you see, using the buffer input stream we can access the file. Now, if I ask you the same thing, instead of buffer input stream, using simple data input stream and data output stream, you can do the same thing, you can do it, actually we have done it already. Now, our next example to illustrate the usage of sequence input stream class. Now, so the sequence input stream class is basically can handle two or more files together, and it will automatically manage it without any intervention within them. Now, here is the program you see. First we create one input stream, file input stream, namely input 1 and another input stream 2. So, here input 1 and input 2 are the two input source I can say, and these are the two source, namely input 1 dot text, input 2 dot text, assuming that they are already present in the directory. Now, here you see we create an object called inst, which is of type sequence input stream. This class is again defined in java.io package. So, we can create an object inst. Now, while we are creating object, you see how we can create the object, passing to input as a overloading constructor of this class, input 1, input 2. Here also we can create input 1, input 2, input 3 also, it will take, the overloading constructor will take it. Now, what it will do is basically input 1 and input 2, the two sources will be scanned one by one, and then the resultant total scanning output will be stored into the inst, and then that inst can be accessed, I can read it, and then finally this inst can be displayed on the screen. Now, here is basically inst, which is basically the result of sequence input stream, and then will be displayed on the screen. So, it will see the input 1 dot text and input 2 dot text, the two content will be displayed on the screen, and finally we close all the stream in input 1 and input 2 from our system. Quick. As you see here, the output as it is shown here, this is the input, this is the input 1. So, actually this is the content in the input 1 dot text and this is the content in the input 2 text. So, two files are sequentially accessed one after another, and it is basically displayed on this one. So, this is the one usage of the sequence input stream class. Another one application of the sequence input stream class, very same, concatenating merging. Here actually we merge, but it merge not stored into the third file. But this program will basically tell you how the merging result can be stored in the third file. It is the same as this one, file 1 and file 2, just like input file 1, input file 2, and file 3 is basically the target third file, is basically we will store the concatenation of the two file. We use the sequence input stream, again file 1 and file 2, that means file 3 will store the merging of the two content. Now using the buffer input stream I can read it and then display it. So here basically in buffer, in out buffer is basically file 3 and output is out buffer, here is basically displaying on the our standard output device. So it is basically using the buffer output stream form, and this program if it is written there, so the concatenation of the two file, the concatenated means merged result will be displayed from the third file on the screen. So this is the program that we have discussed about using the sequence input stream class example, and here is the so this is the again program, as we see this is the input, this is the same thing, that is concatenation of the two input file. Now we will discuss about random access. This is the last content to have the demonstration. Random access is just different mechanism, that totally different than the concept that we have learned so far. In some situation we have to access the file in a random manner. Whatever the things we have discussed, that we discuss the file in a sequence manner, that means one character, the next character, one byte, the next byte until the end of file like that. But here we can read at random. So this program can have a quick demo about it, and you can use the file class for this. So here we just random access file, rather there is a class random access file which is defined in java.i file. We have to create an object for this. So we create the file is a type random access file, and this file whenever we create it, it can be opened in any mode, read, write. So unlike the sequential access, it can be either read or write, but it can be open both mode. Now here we create the file object and then it connect to the file. So we want to randomly access rand data, reading, writing on the same file at the same time like. So here we see we first write something, write character, write int and write double, and these are the input that we have to write into this. That means if the file is blank or if the file is there, if we write it from very beginning, it will be overwriting, then entire content will be deleted and it will store this one. And here is the file seek is basically positioning the file pointer. So it basically 0 indicates that it will position file pointer at the very beginning, that means where the x is now written there. Now here system.out.println find read character, that means presently seek 0, that means start here, this statement will read x, and then again after reading x automatically file pointer move to the next one, that means it come here and read int, it will read this one, go to the next one, read double and it will read this one. So this basically reading and writing from the same file, as we can see there. Now here again seek 2, as you see that file position will be moved to the second location. So 1 2, that means it will go there, and then again we read int, that means we can read the 555 here, and then file seek file dot length. So file dot length, as you know, it will give you the size of the file. So if the seek is go there, means it will move the file pointer to the end of the file, and at the end of the file write boolean false, that means we write a boolean value and the false. And file seek 4, again we go to the fourth position, 1 2 3 4, means it will come here, then we can say file read boolean. So read boolean means it will read false, and then finally file codes. So this basically shows very quickly shows that how the random access mechanism can be applied to a file object. Now here is the quick execution of the program, so that we can run about it, and then we can see the different states that it will show here. As we see here, this is the first read integer, write read character, write integer, and then write double, and then again read, and then again finally go to the file position at the end where the true is stored, and we retrieve it and then get it. So this way we will be able to access the file in a random way. This is a very small example we have discussed about it. Now I hope you have understood the concept of file input output mechanism in Java. The input output mechanism is just started here. The more input output mechanism will be discussed whenever we will discuss the graphical user interface concept. There is also lot of input output in a different fashion, in the different style we have to follow, but all those lessons that we have learned will be utilized there. In addition to these also few more in those contexts we will discuss. Okay, we should wait for the next topics that we are going to cover. It is basically graphical user interface programming, our next topics to be covered. Thank you very much. Thanks for your attention.